Hi everyone, it's me Navin Kharka and I'm gonna do the oral presentation on inductive heating. So what is inductive heating? Technically it is the current generated in the conductor due to a time-varying magnetic field. The magnetic field changes its direction constantly, that's why the eddy currents is formed inside the metal, and this eddy currents is given by the right hand thumb rule. Once those magnetic field lines cut through the metal, the circulating eddy currents loses the energy in the form of heat. And here if you look at this AC source, the magnetic field created by the AC source is bulged outwards and it gets connected with the metal surface, and that's how the eddy currents are formed. The direction of the magnetic field always changes constantly. The time-varying magnetic field is the one which is responsible to create an induced current in the inductive heater, as Faraday's laws says. This is the figure. I'm gonna talk about how it's related to skin depth. As we can see, like the frequency is very high on the surface of the metal, and due to the higher heating there will be less skin depth and there will be small penetration of electric magnetic field and outer surface of the metal. But as you go through inside the metal, the penetration goes exponentially. I mean the function decays exponentially 1/E. As a result, heating is experienced on the surface area only, not inside. And this is the formula for the skin depth. Delta is equals to 2/omega mu sigma. And this is the slides where you can talk about the tangential and normal components between two materials, air and the metal. The tangential electric field is continuous, and that's why it makes the electrons flow. And the normal E field inside the conductor will be 0 because all those electrons will have charge accumulated on the surface, and only the electrons which move creates the eddy currents. And since the metal itself has some internal resistance, it opposes the flow of the current, and the current is converted to heat in induction systems. This is about the engineering application. Inductive heating can be seen in the mechanical work for like fixing gears or loosening belts. Another one is the cooktops. They also use the eddy currents to heat the pan. Even in the robotic industry, you can make the machine work faster, safer and cleaner without even have to touch them physically. Then we can have the most modern recognizable uses: wireless charging. Whether it's smartphones or electric vehicles like Tesla, all the systems rely on transferring energy through a magnetic field using the same principles of inductive heating. So overall, this presentation starts how inductive heating works from the Ampere's law, Faraday's induction, time-varying magnetic field, skin depth and boundary conditions. These theoretical ideas are engineered into practical technologies that we use every day. And here is the reference that I took to create the image for this presentation. Thank you.